Well, students, today I'm going to take a class on combustion reaction, and this is a very important topics. This is a part of organic chemistry where we discuss about alkanes and all. Okay, let me change the slide. Well, let me explain first. That means let me define the combustion reaction. Combustion is a type of reaction where any substance reacts with oxygen. And here the substance which is burned, that is called combust. When a substance burns, it is said to combust. Well, I hope you understood. Let me go further. Then actually we know that the fuel is a kind of substance which we burn in the presence of oxygen, and as a result, for example, hydrocarbons are burns in the example, and for example, and that hydrocarbons actually comes from the crude oil, and when we burn it, we get carbon dioxide, water, and sufficient amount of heat energy. That heat energy can be used as fuel. I hope you understood. Well, let me change the slide now. We know that hydrocarbons are basically used as fuel, and we discussed it in the alkene and alkene chapter. And whenever the hydrocarbon will be burned, we usually get carbon dioxide, water, and sufficient amount of energy. It is a kind of exothermic reaction which gives energy, heat energy, and that heat energy is used in the practical field to run the cars, to cook in the kitchen, or to use it in industry, chemical industry, whenever we need any heat energy for the process. Well, let me change the slide now. So during combustion reaction, whenever hydrocarbon, which will be used as fuel and it will be burned, then both hydrogen and oxygen will be reacted with oxygen. Whenever carbon and oxygen will be reacted with oxygen, that is actually oxidation reaction. And we know we have already learned the oxidation reaction, right? The oxidation reactions are that kind of reaction when oxygen will be gained or oxygen will be added. Another definition of oxidation reaction is it can be explained by losing losing electron. Okay, but here we need to understand that whenever oxygen will be added in a chemical reaction or oxygen will be gained, that is oxidation reaction. So here you can see the example from hydrocarbon. Whenever the carbon reacts with oxygen, then we get carbon dioxide, and this part of the reaction is definitely oxidation reaction, right? I hope you understood. Because here, before the reaction, we have only carbon, but after the reaction, carbon gains oxygen. As a result, carbon dioxide is produced. On the other hand, removal of oxygen is reduction reaction, and we know that reduction is just opposite of the oxidation reaction. So whenever the oxygen will be removed, that is reduction reaction. So here the example can be given. Let's see the reaction. Copper oxide is the substance which produces copper whenever it reacts with hydrogen. That means oxygen is removed from copper oxide. So the part of the reaction where from copper oxide we get copper, that is a reduction reaction because oxygen is removed from copper after the reaction. Before the reaction it was copper oxide, but after reacting with hydrogen it gives copper. That means this part of the reaction is a reduction reaction as sorry, I have explained that when oxygen is removed, yes. oxygen is removed from copper oxide. So this part of the reaction is reduction reaction. I hope you understood. Let me change the slide now. Now, combustion reaction is basically two types. First type, it is a complete combustion. Complete combustion happens whenever any substance reacts with oxygen in the presence of excess oxygen. Whenever the amount of oxygen will be excess, then that reaction can be considered as complete reaction. Here we see the flame. Whenever Bunsen burner is burned, is anything is burned, we see a blue film, blue flame here. So part of the blue film is the is actually due to the result of the combustion reaction, complete combustion. So part of the blue flame, as I have mentioned, is actually complete combustion. Here it is said that hydrocarbon, pure methane is burnt here. Pure methane, if is burnt here, so in presence of sufficient oxygen, so it is actually due to the result of the combustion, complete combustion. So we can see the actual reaction so that we can understand whenever hydrocarbon, which is available in the crude oil, is burnt in oxygen, then we get carbon dioxide and water. So this is the complete reaction, combustion reaction. Carbon burns in oxygen, hydrocarbon burns in oxygen, so we get carbon dioxide, water, and also we get heat. Heat is the main, very important part of this reaction because that heat will be used in the practical field. Let me change the slide now. So, as I have mentioned, that methane is a part of hydrocarbon, right? Methane contains carbon and hydrogen. So its formula, we know it is CH4. So it is a very important part of hydrocarbon. So whenever the methane gas is burned, it is combusted in oxygen to produce carbon dioxide and water. So it is an example of combustion, complete combustion, because their amount of oxygen is enough. On the other hand, if we burn uh, propane in the presence of sufficient oxygen, we will also get the same product, carbon dioxide and water. Maybe the balancing will be different. The products are same. So this is actually another example of combustion reaction. Let me show you more example in the next slide. Okay, so here you see that methane is burnt in oxygen, propane is burnt, then ethane is burnt also. In the last one, methanol is burnt in oxygen. In every case, we get carbon dioxide and water. Here the balancing is very important. You know that balancing is the making number of atoms equal in both sides of an equation. Here we see that whenever methane is burnt in oxygen, number of carbon in the left side is okay, but number of hydrogen in the right side it is shown only water. In water, it is shown only two hydrogens. So for balancing hydrogen, we have to put two in front of water. As a result, now check back. Whenever we will balance, always we will check back. So if we check back, then we see that number of oxygen is in total 4, right? Because if we put 2 in front of water, then we have 2 oxygen and 2 oxygen in carbon dioxide. So number of oxygen is 4. So for balancing number of oxygen, we must have to put 2 here, and that is already put here. You can see the next example, propane is burned. The product is are same, carbon dioxide and water. But let's see what is about the balancing. If the number of hydrogens are not equal, so the number of hydrogen is here 8, but here it is 2. So you have to put 4 in front of water. As a result, number of hydrogen will be balanced in both sides. Now, if we check back, you see that number of oxygen in the right will be total probably 3 to the 6 and uh, 4 here. So total 10. 10. So number of oxygen is 10 in the right side. So balancing number of oxygen already 5 is put here. So the equation is properly balanced. Now let's look at question number 3, equation 3. Here ethane is burned in oxygen. So number of carbon is not balanced. So you have to put 2 before carbon dioxide. Right, if you put 2 before carbon dioxide, then number of oxygen will be 2 to the 4, and see here oxygen hydrogen is balanced, right? So let's see what is about the number of oxygen. Now check back. So if we put 2 in front of carbon dioxide, 2 to the 4 oxygen is there, and here 6 oxygen is here. So that means total 10 oxygen. So for you have to put 5 before oxygen. As a result, number of oxygen will be balanced properly. No, sorry. Here you have to put 2 before carbon dioxide. You have to put 4 before carbon dioxide. As a result, number of oxygen is 8 and number of oxygen is 6. So 8 plus 6 is 14. So to adjust the number of oxygen, you have to put 7 before oxygen. I hope you understood. Now let's see the last one. Here, carbon is already not balanced. Carbon is here before carbon it is 2, and hydrogen is here. Number of hydrogen is taken here is 4. 4. So we have to put 4. So the hydrogen number of carbon is 2. So you have to put 2 before this methanol. As a result, number of hydrogen is becoming 8. So to adjust the number of hydrogen, you have to put 4 before water. As a result, number of oxygen will be 4 and 2 to the 4. So 4 and 2 to the 4, that means 8. Sorry, let me check it again. Here, number of carbon, I think it is not balanced. Now we should not have anything before carbon dioxide. As a result, number of oxygen you have to put to 4 here before H water. Then, sorry, number of hydrogen is 3 to the 3 and 4, 6. As a result, number of oxygen is here it is taken 3 to the 6 and 1, 7. 3 to the 6 and 1, 7. So if we put 2 to the 4 and 3 before water, then everything will be balanced. You have to put just 3 before water for balancing the reaction properly. And before methanol, you have to put 2 as well. I think then the equation will be properly balanced. Let me change the slide now. Well, fuel and environment, this is the topic here. Most fuels contain hydrogen and carbon, but many also contain some sulfur, right? Sulfur is also sometimes mixed with the fuel. As a result, we will get few products here. We will get carbon dioxide, water, then also we may get carbon monoxide if it is in complete combustion. Then due to the presence of sulfur, you will get also sulfur dioxide. So these are the products which we will get whenever uh, the fuel containing sulfur will be burnt. And these are actually called particulates. And also you may get nitric oxide, as the fuel may also contain nitrogen, right? Well, so these particulates are basically responsible for the greenhouse effect, because these particulates can trap the heat close to our land area, as these will be the products whenever fuel is burned in oxygen. It is a fact that whenever any substance is burnt in pure oxygen, not in air, then it will give more heat. Okay. So, and the burning will be rapid as well. That is why with propane, oxygen gas is mixed, so that it gets more heat, like 3500 degrees Celsius, and at that high temperature, the metals can be melted. So the pure oxygen instead of air also contain oxygen, right? 21% oxygen. But if we instead of air, if we use pure air, then more extra heat will be given. I hope you understood. Let me change the slide now. That is the end of the topics. I hope you understood. Still, if you have any confusion, please let me know. Well, I hope these topics will help you. And this is actually, as I have mentioned, the part of the fuel chapter, that means alkene this chapter. And these things are very important for us. Thank you very much.